I'm going to go through this with you, check your answers. I'm going to keep throwing simplifying trig expressions at you. Here is the reason why. Are you ready? Tomorrow, all our trig equations are going to require your use of identities. So all the stuff we did with proof and simplifying is going to show up now in equations. So it is going to be joyful. We might actually see it. All right, I'll use red so we can see it. But number one, I'm going to go really quick. Here we go. This will be cotangent. It's cosine t over sine t times sine t. What happens to sines? Cancel. You end up with cosine t. Number three, all right, I'll go this order here. These are reciprocal, so what's the answer? 1. These are reciprocal, so what's the answer? 1. 1 becomes this answer kind of like in Sunday school class when the answer is always Jesus or God. So don't just say 1 just to say 1, because it will take me off. Because last hour they would just kept saying, is it 1, 1, 1, 1, 1? And then you're kind of like that stupid bird on Finding Nemo. Mine. All right, so don't just say 1 just because you don't know any other answer and 1 seems like the right answer, okay? Because, you know, in Sunday school class, you just be like, you're not even listening to your Sunday school teacher and be like, question, and be like, Jesus? Yeah, that's right. And, or God, or whatever. All right, cosine t over sine t times 1 over cosine t, what happens? Cancel, we end up with 1 over sine t. What's 1 over sine t? Cosecant t. All right, factoring is your friend on number 5. Number 5, so what do?
Factor it.
If you say 1, I'm going to... It is 1. So sine, see now you get my point. 1 plus cotangent squared t. What is 1 plus cotangent squared t?
That is secant.
Cosecant squared t. Why am I doing that? Alright, so you got sine squared t times cosecant squared t. These are reciprocal, so yes, the answer is 1. Yes. Heidi, you were right. Alright, what about the top? 1. It is 1. Sine squared t. The top is 1. That's a Pythagorean identity. You need to know those. They're going to come up a lot now. And then this will be cosecant squared t because of the identity. What about 1 minus secant squared t? It's not 1 this time. Tangent squared t.
Isn't it negative?
Yeah.
No. Maybe.
Yeah.
1 plus tangent squared t equals secant squared t. Yeah, it is negative. I told last hour wrong. Oh well. All right. Next one is sine squared t over 1 minus cosine squared t over sine squared t. What happens to sine squared t's? They cancel. And then what's 1 minus cosine squared t? Sine squared t. So there's that one. This was negative apparently. All right. Next page, 9 through 12. Everybody made such a big deal about 9 through 12, but I already taught you how to do these. You've got the cofunction identities were this. We probably did it in degrees when you did it. But sine of 90 minus x, 90 degrees minus x is equal to cosine x, which is the same thing as sine of pi over 2 radians minus x, which is equal to cosine x. And the same comes true for all your other cofunctions. Sine and cosine are cofunctions. Cotangent and tangent are cofunctions, and secant and cosecant are cofunctions. So you can do tangent same way. Tangent of 90 degrees minus x is the same thing as cotangent x, and you can do it the reverse too. You can do cosine of 90 minus x. Cosine of pi over 2 minus x is the same thing as sine x. Tangent of pi over 2 minus x is the same thing as cotangent x. So those are your cofunction identities. We don't use them very often, but when they do pop up, it shouldn't be a big deal. These are the more important ones, the even odd ones that I taught you. And let's see if you remember them. Sine of negative x. What can you do? What can you do with the negative when it's sine? Because it's an odd function, because it's symmetric about the origin, which means you flip it over the x and y, you can bring the negative out front. Okay, what about, now, does anybody know if sine is odd, what about its reciprocal? Isn't cosecant based on the graph of sine? When you graphed cosecant, didn't you graph sine first to graph cosecant? So if sine is an odd function, what do you think cosecant is? Cosecant is also an odd function, so the same rule works for cosecant. You can just pull the negative through. Okay? I've been over that a few times. Symmetric to the origin. Remember? You remember now? Okay. You might have been gone when I did that. So we did it again. What else was an odd function? Cosine was what? Cosine was an even function. We'll get to that one in a second. Cosine, well, I'll do it right now. What do you do with cosine negative x? Drop the negative. Cosine x. And if that's true, then its reciprocal is also true. Now, I'm going to go ahead and tell you right now, you hardly ever do the reciprocals with an even odd function identity. If you just know the sine one and the cosine one, it's just extra if you know the reciprocals abide by the same rule. Tangent, though, which one's tangent? It is odd, and it's because it's based on a disco curve, which is an odd function. Okay? And you get
Negative tangent.
oh, that was weird. Negative tangent x.
Yesterday he was doing a skit.
Yeah, I know, he's doing Hamlet or something. Yeah, it's weird. I don't know about cotangent. Cotangent, would it be? Cotangent would be an even function, wouldn't it? Well, let's see. It goes, watch. It goes asymptote, point, asymptote, point, asymptote. Is that symmetric to the? No, it doesn't. His what? No, whatever business. No, whatever me ever again. Okay.
It's not symmetric to the y.
It's not, but it is symmetric to the origin. If I flip it over both, do they match up?
Yeah.
So it is odd. Cotangent's also odd.
Quad.
I couldn't remember. I just want to make sure I didn't screw it up. Now, I don't know if I ever used that one. The ones that I use are these three. Okay? You will use these three. And they're helpful here. Because in number 9, the directions say sine t is equal to 3/5. And I'm going to remind you something we did a while back that comes in handy here and that we will continue to use. And you got to keep in your brain somehow. If this sine t is equal to negative t, this is really what?
Negative sine.
Negative sine t. And the directions tell you sine t is what? So what's the answer? Negative 3/5. Ooh, did anybody get that one on their own? 1.
Yeah, but I
Two.
did it different.
Just plugged in the T.
You just guessed it? Did you guys actually understand that?
No.
Who got it on there? David, did you just know that? Did you get that?
Yeah, I got it.
And that made sense?
Yeah, but then
David,
The other ones? David, you're a rock star. This one right here,
the other. Did you get him on?
watch 9 and 10. Since they're the same, we'll just do 1 if you're okay with that. We can do it twice if you want, just to be. All right. This right here is your cofunction, so this equals cosine t. Agreed?
Yeah.
All right, that part, easy. Next part, just as easy, I think. If you remember, sine t, in the directions they said is 3/5, but you need to remember sine was defined as y over r. And if you want to find cosine is what? X over r. We've got y. Y is what? R is 5. How can I find x?
Pythagorean theorem.
Pythagorean theorem, or you can just recognize it's a special right triangle, the most special right triangle in all of mathematics. It is a 3, 4, 5 right triangle. So x is 4. That means cosine t would be what? 4/5. That will come up. That actually came up last year on the AP exam free response part A. You had to know sine was y over r, cosine is x over r, because they gave you a non-calculated problem and they gave you one of the ratios and you had to find, I remember it, it was secant x you had to find. You had to remember it was r over x. Be able to do it, because they didn't give you a calculator. All right, tangent of negative t. Negative tangent t. Now we've got your x, y, and r. So what is tangent?
3/4.
Negative 3/4. There it is. Okay? Any questions? Does that make sense? Okay. Well, it'll pop up every now and then, and you know when you see it every 3 or 4 weeks, you start to realize the things that you're going to have to keep there handy and at the top of your list of things to remember, I guess. Next part here, this one right here, I'm not going to elaborate on this much more than this is just sine squared t minus cosine squared t. It does go simpler, but I haven't taught you that identity yet. There's 2 more identities I got to teach you. 14 is sine t over sine t divided by cosine t, and then you just multiply by the reciprocal. So it'd be sine t times cosine t over sine t. What happens to sine t? Cancel, so the answer is cosine. This next one, factoring is going to show up tomorrow when we solve equations. So what's the top factor into?
Cosine plus 2 squared.
Cosine t plus 2 times cosine t plus 2, or you could have written, like Billy said, cosine t plus 2 quantity squared, because it's the same thing twice. And how many of them are going to cancel?
1.
One of them, so you're left with cosine t plus 2. Fairly straightforward. This one right here, I think you're going to need a common denominator for, maybe. Minus sine times sine over cosine. Yes, happens to have a common denominator. How nice is that? So you're going to get 1 minus sine squared t over cosine t. What's 1 minus sine squared t?
Cosine squared.
Cosine squared t. What's cosine squared t divided by cosine t?
Cosine squared.
Cosine, one of them cancels. There you go. Next one right here. This one's kind of this is fun. This right here. What happens when you square sine?
Sine squared.
Sine squared. That's going to cancel then. What happens when you square 4 cosine?
You square the 4 and you square the cosine.
So you get 16 cosine squared t. What happens to cosine squared?
Cancel.
But the 4 doesn't cancel. What do you get? You get 1/4. Okay? That one wasn't too bad. I think the next one's even easier. Okay? And the third worksheet I thought was the easiest. They agreed after 2 problems.
The last one was time consuming.
I didn't show any work on them.
Yeah, that's why it was time consuming because we had to do everything in our head.
Oh, I don't think it's that hard. I think you're going to feel like it wasn't as hard as you thought. But I am going to go through every one of them, though. All right, here we go. 1 over sine theta times cosine theta. That's coup. Cosine theta. I haven't taught you coup yet. All right, sine theta over yeah, it's a thing.
I'll Google it.
You never heard of cooing? Babies do it. All right, 1. There you go. There's your answer, 1. Go ahead, Heidi.
Oh, yeah.
1.
Seriously?
Seriously, it's 1. All right, this will end up being cosine times 1 over sine, which is what? Cotangent.
Oh, I
Secant squared theta minus 1. Tangent squared theta. There's sine over cosine. What's going to happen to cosines? Cancel. So this is going to end up being sine. What's sine x plus sine x? Thank you. It is not sine squared x. It's 2 sine x. Okay? It's 2 sine x. This is just 1. This one's cosine squared x over sine squared x, which is what? Cotangent squared x. Okay, good. Any questions there? All right. This one right here, I think I actually did on the test. This one was secant squared x over cosecant squared x. And the quick way to do this, you don't have to show a lot of work anymore because if you're not proving, you can skip steps. We can just move secant to the bottom and it becomes what? Cosine squared x. What happens to cosecant when you move it to top? Sine squared x. What's sine squared x divided by cosine squared x? Tangent squared x. This will just be 1 over sine squared x, which is what? Cosecant squared x. This one right here, you can factor out a cosecant x. You're going to be left with 1 minus cosine squared x. What's 1 minus cosine squared x? Sine squared x. This is just 1 over sine times sine squared x. What's sine squared x times 1 over sine? Sine x. And this one right here. All right, you ready? Use, I think it's problem number 6 or 5 or whatever. And does anybody have any ideas how I can do this one? Yes, David. Yeah, the bottom turns into secant squared theta minus 1.
You can put it in terms of cosine.
Could, but I'm not going to. And you'll probably get there. I'm going to get there. Huh?
What did you do?
I used Pythagorean identity. You see what I did? Now, what's the bottom factor into? There you go. The bottom factors into secant theta plus 1. Secant theta minus 1. What happens to secant theta plus 1? Cancel. Final answer. 1 over secant theta minus 1. All right.
That's applied to.
Nope, that's as far as I want you to go. Here we go.
Okay.
Next worksheet. This one. I just click it again. Just be patient. All right. This one, it hinges on whether or not you're going to be successful the rest of the way. Okay? I will take my time, but as soon as we get past 2 problems, you're going to want me to speed up. This gets real easy real quick. Okay, I will go through it again with you. We explained this yesterday, talked about it yesterday. Today I'm going to go to the calculator, and the calculator gets more complicated. Okay? All right. Well, we said there's 2 types of trig equations. Now, last night, I feel bad because I thought I changed my second set of directions to where you were supposed to solve for all the solutions, but I had you only do from 0 to 2 pi last night. So the whole assignment, you were only giving me how many answers? Up to 2 answers. Were there some problems that had no answers? Yes, there was one. Were there some problems that had only 1 answer? You probably saw those for sure. There are some problems. There can be 2 possible answers, but it doesn't mean there has to be 2. There was a couple problems on here where there was only 1 answer. And there were a couple problems on here, actually, no, there was only 1 problem on here where there was no solution. And I'll talk about that when we get to it. Okay? The stuff we did yesterday in class, though, is going to really have implications on what you do tonight with the decimal stuff. Because tonight is going to be a lot of decimal stuff because you're going to be using the calculator. Okay? So let's get these exact ones down. Because tomorrow, when I start throwing in the algebra, all of a sudden your problem is going to go from 1-step problem to about a 6-7-step problem. And we will have some ones where we even do quadratic formula with it tomorrow. Remember the good old quadratic formula days? We got a problem tomorrow, we're going to have quadratic formula, and I think there's 8 answers in it. Okay? And you will see how it's done. Alright? Now, let's start with this one. Here's the deal. When I start solving more complicated trig equations, everything hinges on you being able to do this. Get it down to a single trig ratio. You have to be able to get your problem down to a simple trig ratio. These are what you call simple trig equations. Simple trig equations is when it's down to a single trig ratio with no power on the trig ratio. Okay? You got to be able to do these, and you got to be able to do them fast. And how many realize it's just unit circle in reverse? It's just unit circle in reverse. In fact, you do the exact same steps. You figure out what quadrants, they're positive and negative. You figure out the reference angle, and then you give the answers. Okay? Now, you are using inverse trig, but nobody thought you were using inverse trig last night.
I did.
Okay? Hopefully you realize you are using inverse trig. You just don't write it. Why? Because how do you do your inverse trig? You think about the what? Unit circle. You do your inverse trig just by thinking about the unit circle. Today we're actually going to have to use the inverse trig function because we won't have the unit circle to go backwards. You'll actually have to type in inverse sine, inverse cosine, inverse tangent on your calculator to get your decimal answer because it's going to be an answer we don't know off of the unit circle. All right, well, let's start with this. The first one, number 1, is secant theta is equal to 2 root 3 over 3. And the first thing people notice is when they look at this is they say 2 root 3 over 3, what's that? You need to know your reciprocals of all your special angles on the unit circle. All right, let's start with probably the hardest one on there, 1/2. What's the reciprocal of 1/2? 2. You know that one. So the reciprocal of 2 is 1/2. What's the reciprocal of root 2 over 2? Root 2. So you know the reciprocal of root 2 is root 2 over 2. What's the reciprocal of root 3 over 2? 2 root 3 over 3. So what's the reciprocal of 2 root 3 over 3? Root 3 over 2. You need to know that. What's the reciprocal of 1? 1. What's the reciprocal of negative 1? Negative 1. What's the reciprocal of 0? Undefined. What's the reciprocal of undefined? 0. All right, you know them all. So now we can start. I told you yesterday, you do not need to write a lot of work down for these. Here's what's happening. You're actually changing this into 1 over cosine. Don't write this down, just watch. And this is still 2 root 3 over 3. And then what you do is you say, okay, I got to get the cosine out of the denominator. So you can multiply both sides by cosine and then divide by the 2 root 3 over 3. Or you can just simply say, since I know this is 1 over cosine, and since the other side's 2 root 3 over 3, and really what I want to do is get the cosine on top, I can just do what to both sides? You can just flip both sides. So we don't even show this step. You just go ahead and flip both sides, and you get root 3 over 2 is equal to cosine theta, and then you say, fine, I'm not showing that step. I expect you not to show that step. I want you not to show that step. I need you to not show that step, because it's just a waste of time. You just need to know if I see secant, I can change it into cosine as long as I do what to the other side. You can't just flip one side. If you flip one side, what have you done? You changed the problem. And now you're totally wrong. You got to flip both sides. So now once you get to this point, I'll go slow for a couple of these problems, and then you can tell me when you're ready to speed up. They were ready to speed up after 2, so hopefully they'll be ready too. Okay, cosine theta equals root 3 over 2. Now here's what I do next. I say, okay, I think about where cosine is positive. Where's cosine positive? What quadrants? 1 and 4. If you have to write that down, write it down. And then I think about, okay, where is cosine equal to root 3 over 2? And not even trying to answer the question yet. I just say, where does cosine even equal root 3 over 2? What reference angle does cosine equal root 3 over 2? 5 or 6. So once I figure that out, now I take and I go back and answer the question. So now I'm going to say, okay, my answers then, go to quadrant 1, pi over 6 reference angle. Well, that's just pi over 6. Okay, so that one's done. What about quadrant 4 with the pi over 6? 11 pi over 6. I actually would tend to agree the other way, or disagree with you guys and say it's easier to go this way than it is the other way. I think I have to do more thinking when I'm thinking about secant of 23 pi over 6. That to me requires more thinking. This is quick, because once you know the reference angle, most of you know one rotation really well. And once you see pi over 6, you're like, quadrant 4, oh yeah, 11 pi over 6. Quadrant 3, oh yeah, 7 pi over 6. Quadrant 2, oh yeah, 5 pi over 6. Quadrant 1, oh yeah, pi over 6. Pi over 4s are easy. Pi over 3s are probably the ones you have to think about the most. But even those, you're just like, okay, 1, 2, 4, 5. Once you just remember it and you'll work with it enough, you'll be like, okay, 1, 2, 4, 5. And so once you get the hang of it, it'll go quicker. This one, you don't need to do anything for it, because where's cosine equal negative 1? There's only one place. Pi. Done. Don't have to show anything there. Okay? Does that make sense? Okay? I'm going to go through all of them. I want to make sure, because tomorrow and today, being able to do the rest of the stuff really matters if you can do these easy ones. All right, what am I going to change cosecant into? Let's go fast now. Sine. So sine theta is equal to what? Flip. Negative root 2 over 2. Okay? I know it's negative, so what quadrant am I going to be looking for? Quadrant 3 and what? 4. What reference angle is root 2 over 2? Pi over 4. So theta equals what? Quadrant 3? 5 pi over 4. Quadrant 4? 7 pi over 4. Do I have to show any of this work? No, just keep track of all that in your head if you want. All right, cosine equals a negative. What quadrants? 2 and 3. What's root 3 over 2? What kind of reference angle? Pi over what? 6. All right, quadrant 2, what is that going to be then? 5 pi over 6. What about quadrant 3? 7 pi over 6. Done. That's all you got to show. Okay, you don't have to do anything else. Okay? What about this one? Quadrant 1 and 2. Pi over 4 and 3 pi over 4. What about the next one?
Quadrant 1
Quadrant 1
and 4.
and 4. So what is it?
Pi over 4 and 7 pi over.
Pi over 4 and 7 pi over 4. Good. Now tangent and cotangent I have to do a little bit more with.
Take on.
Okay?
Actually, I did less with that.
On the ones that are 0 and 1 probably. Maybe with the root 3 over 3 and 2 root 3 over.
Yeah.
Those you have to do a little bit more. But here's what I do for tangent. I just go sine over cosine. And now that this one equals 0, it's real simple. I just need sine to equal what? So where did sine equal 0? Come on, where's sine equal 0?
0 pi.
0 and pi. That one's done. Now this one you might have to do a little more work with. So here's what I do, and this hopefully will help. You have sine over cosine. And you want it to be positive root 3 over 3. So let's deal with the positive first. Where is it going to be positive? Where sine and cosine have the same sign.
1 and 3.
So 1 and 3, they're both positive in quadrant 1. So positive divided by positive, positive. Quadrant 3, they're both negative. Negative divided by negative is a positive. Agree? Now, here's what I do. You only got so many possibilities for sine and cosine. Negative 1, 1, 0, root 3 over 2, 1 half, and root 2 over 2. That's it. That's all you got to work with. 1, negative 1, 0, 1 half, root 3 over 2, root 2 over 2. You know it's not going to be the root 2 over 2's. Because when that's the case, it's pi over 4's, and they're both the same, and that's going to give you 1 or negative 1. Are we dealing with 1 or negative 1? So, you know you're not going to do a 0, 1, or negative 1. You know you're not going to do the root 2 over 2, so the only possibility is 1 half and root 3 over 2. So you just got to monkey around with the 1 half and root 3 over 2 so that you can produce that. Well, if I put the 1 half on top and the root 3 over 2 on bottom, that'll cancel the 2's and you'll be left with 1 over root 3. Will that give me the root 3 over 3 I want? If you would have done it the other way, you would have been just left with what? Root 3. That's not what I want. I want the 1 half on top, the root 3 over 2 on bottom. What reference angle is sine 1 half and cosine root 3 over 2? Pi over 6. So once you figure that out, you say, okay, my answer is quadrant 1, pi over 6. And then what about quadrant 3? 7 pi over 6. Okay? Cotangents, cosine over sine. Where's cosine? 0. Well, where's cosine 0?
Pi over 2 and 3 pi over 2.
Pi over 2 and 3 pi over 2. Secant theta equals negative 2. What do I do? Reciprocate it. Okay? So it's negative in quadrant 2 and 3. So what are the answers? 2 pi over 3 and 4 pi over 3. So that's pi over 3 reference angle. Okay? Next one, sine theta is equal to negative root 2 over 2, quadrant 3 and 4, so 5 pi over 4 and 7 pi over 4?
Yeah.
5 pi over 4. I'm just going to give you the answers now, and then if you need help to stop me. This will be sine is equal to root 2 over 2. I think these are a lot of repeats. That'll be pi over 4 and 3 pi over 4. Okay? Next one, this will be, ooh, this one's interesting. Ready? Cosine theta equals 2 root 3 over 3. I'm going to bring this up in a minute on some of the examples you're going to do with the calculator day, but can somebody tell me what you got for this one?
Huh?
What'd you get for this one?
No answer.
No solution. Can somebody tell me why from yesterday? Exactly. It's bigger than 1. We said the domain. I know you don't think of it as doing inverse cosine, but you're actually doing the inverse cosine. And I'm going to write this down again today before I give you the examples that I'm going to go over with you. You can't do the inverse cosine of something bigger than 1 or less than negative 1. Same thing for inverse sine. Okay, because on the unit circle, sine and cosine only go up to 1 and negative 1. Okay, so the domain for your inverse cosine and inverse sine is between negative 1 and 1. This one right here is what?
2 pi, or 0 or pi.
0 and pi.
Why can't I say 2 pi?
I don't want it.
Technically 2 pi's right.
It is, but it's redundant if you're just naming 0 again. This one right here would be sine theta is equal to what? Negative root 3 over 2, so that'll be 4 pi over 3 and 5 pi over 3. This one is 0 and pi again. This one is pi over 6 and 11 pi over 6. This one right here, cosine over sine. Let's see, if I want root 3 over 3, I'm going to again have the 1/2 on top, the root 3 over 2 on bottom, right? 2's cancel. Will that give it to me? So where's cosine 1/2? Pi over 3. So quadrant 1, it's going to be pi over 3, and quadrant 3, it's going to be 4 pi over 3. Cotangent equal to 0 is going to be pi over 2 and 3 pi over 2. And then sine equals -1, that'll be 3 pi over 2.
5 pi over, oh wait, no, that's 2 pi.
All right, let's go ahead and